Hi, everyone. I am Akshat Gupta. A little bit about me. I was an undergrad at IIT Mandi doing my BTech in electrical engineering. After that, I recently finished my master's from CMU, where I was primarily working in NLP. And in this video, I want to introduce you to one of the research areas that I was working on at CMU, with the idea that you might find this domain interesting and might want to take up one of the problem statements as your course project. And yeah, so one of the areas I was working on while I was at CMU was semi-supervised learning and NLP. And in this, so I'll give a brief overview of or a brief background of semi-supervised learning and the kind of problems we were working on. So let's start with the very basics. What is semi-supervised learning? So semi-supervised learning is a paradigm in machine learning, which is just slightly different from supervised and unsupervised learning. So supervised learning is where, like, to very simply put it, you have labeled annotated data. And in unsupervised learning, that's not the case. We don't have annotated data. So a very common supervised learning problem is a classification problem, like MS digit classifications or ImageNet classification, or something as simple as sentiment classification in NLP. Unsupervised learning, we don't have annotated data, so we have to find patterns in data without much without, let's say, so without supervision, and clustering problems are the most common there. Semi-supervised learning is the third paradigm, which kind of we're dealing with, where we have small amount of annotated data available and a large amount of unlabeled data. And this is a very common scenario, especially in industry where you don't have a lot of labeled data. And the aim here is to find algorithms or techniques that are best able to leverage the unlabeled data that is usually available in large amounts, with taking some help from the small amount of annotated data that we have, and usually some kind of teacher-student methods, self-training being one of the more popular ones. So that was a very small, short, quick introduction to semi-supervised learning. Another thing we often like talk about is transfer learning in NLP, and something that we do in our daily work, especially in the problems I was working on. So what is transfer learning? Transfer learning is like a way where we're focusing on using the knowledge gained while solving one problem and applying it to solve another problem. So a basic description of that would be, let's say we have a task one task that we have to do, and we have data for that task, and we train a model for that task on this data, and we make predictions for the task. So let's say it's a very simple classification task. Now, this model is usually initialized randomly and it's trained from scratch. Now, when we're doing transfer learning, what we do is, like, for another task, say task B, we have separate data for this task, but now the model is not initialized randomly, but is initialized as the model that we had for task A. So this, in some sense, incorporates the knowledge that we had stored from the previous task, and we use or incorporate that in solving the next task. And you could imagine how that's important in real life, because you don't always have large amounts of labeled data, and you want to train models effectively. So we use a pre-trained model, like something which is almost very commonly done in different image classification models. We're always initializing a lot of models using different, like, ImageNet based models, like initializing with ResNet 50, ResNet 34, and then fine tuning those models on the data set that we have. So that's transfer learning. And we in our work are especially focused on cross-lingual transfer and domain transfer in NLP. So what is cross-lingual transfer? Cross-lingual transfer, by that, what we want to do here is leverage this idea of transfer learning between two languages. So the idea of transfer in knowledge between two languages. So in this scenario, what would happen is like model one or the base model is trained on a high resource language, usually say English. And say we want to do like a task like sentiment analysis on a language like German. We don't have enough annotated data for German, but we have a model trained on English, on a large English corpus. So we use that model, we initialize our model for the German language using that English language model. So we're basically leveraging what knowledge we have about understanding sentiment in English to understand sentiment in German. And that's the idea behind cross-lingual transfer. Is yeah, it's basically that. It's so this cross-lingual transfer, you need some understanding of the languages to be able to best do that, because let's say if there is a language like Mandarin, which is linguistically further from uh, English than German. German is linguistically a closer language to English than Mandarin is. So it's better to use English for German than it would be to use English for cross-lingual transfer for Mandarin. So it's like these nuances, that's something we have to understand. For example, if our target language here is in model 2 is Bengali, it's better to have a pre-trained model on Hindi than on English, or better to have it in English than in Mandarin. So that's kind of, these are some things we keep in mind while best leveraging this cross-lingual transfer. Another thing we look at is domain transfer and leveraging transfer learning between two domains. And a typical scenario here would be, let's say we want to do sentiment analysis of Google Newsfeed, but we don't have enough label data for it. But we have enough data for sentiment analysis on Twitter, tweets, basically. So we want to transfer this knowledge between domains, and domain transfer, though, may be simpler than a language transfer, but it's not trivial. So don't expect that something that works on Twitter news data set will automatically work on a Google Newsfeed data set. So this kind of a transfer is also something we do. We look at in our work. And another thing we look at in our work is code switching. So what's code switching? Code switching is the practice of alternating between two or more languages in a conversation. So it's commonly done in India, where we mix Hindi and English almost every day. Other common examples are Spanglish, which is done very commonly across South America, Mexico, Chinglish, which is pretty common in Singapore, Tanglish, which is like code switching of Tamil and English, and other code switch languages. So this is another thing, another aspect of our work is transfer learning, and also we tend to work with code switch languages as well. So that was like a brief overview of what we work on. It's kind of related to semi-supervised learning, transfer learning, cross-lingual transfer, domain transfer, and code switching. So that's the kind of domain we're in. And just to give you an idea of the problem statements that we're interested in. So I've previously worked on unsupervised or semi-supervised algorithms for leveraging cross-lingual transfer, domain transfer, active learning, online learning, these kinds of problems. And we came up with an entropy minimization version of self-training, which we saw it works on sentiment analysis of a two-class problem. We want to see if it works on other problems, or even image classification. Does it generalize to non-NLP based problems? And that's a very interesting and novel thing to look at. So these are, like, to give you an idea, this is like the basic setting which we're in, semi-supervised, unsupervised, methods, basically trying to best leverage transfer learning for certain tasks, dealing with lots of languages. So if you like languages, if you like NLP, if you want to get into NLP, I think this is like a very exciting domain. This is also very realistic in terms of that in industry, we are always lacking data. For low resource languages, we're always lacking data because there are way more low resource languages than there are languages for which we have decent amount of annotated data. So in general, we'll always need such techniques. And that's what kind of makes it interesting, using different algorithms, bootstrapping to make this work. So these are some example problem statements, and I'd love to discuss if any of these problem statements or the domains interest you. I would love to discuss them with you. And yeah, and if not, I'd be very interested in just coming up with our own problem statements. So feel free to contact me, email me, or connect with me on LinkedIn, and we can talk there as well. My contact would be in a later slide. And yeah, so this is one of the papers that we worked on unsupervised self-training, which basically was creating an algorithm that is able to leverage cross-lingual transfer in the best way for an unsupervised setting. And yeah, so I guess that is, I think my contact details are not in this presentation, but I'm sure they'll be shared with you in some way through an email, or it's definitely there in my next presentation, in my other presentation on spoken language understanding, but I'll make sure it's there. So yeah, feel free to contact me if you're interested, if you want to discuss more. And yeah, thank you.